Good morning, class. We're going to start today by going over the assignment that will hopefully be posted later today. This is a very beta version of this assignment. I'm not actually sure if I'll be able to get it done, get it ready to release by the end of the day today. So, can't exactly ask myself for an extension, but if the assignment isn't ready today, I'll shift the due date back a little bit so everyone kind of gets the extension, and you'll get 2 weeks to work on it either way. Might just make the due date be the last day of classes anyway. I'll have to check in with the markers and see if they have enough time for everything. Anywho, next assignment is going to be talking about graphs. We're going to be talking about graphs today if we get through AVL trees quickly enough. Sort of a similar idea to implementing binary trees from the previous assignment. You'll be given some code that's just a skeleton of the class you'll create, and you'll implement the main methods representing the operations on the ADT. There are multiple different data structures you could use to make a graph. We'll cover both in class. I just wanted to point that out to tell you to read the whole question before starting, because you may be able to figure out which data structure would make things easier. The first real question is solving some problems from graph theory. Maximum independent set, minimum vertex cover, and maximum clique are just different, properties you could figure out of a graph using an algorithm. These are all in a class of problems called NP-complete. Informally, it means that they're difficult and that any algorithm for solving them will take exponential time, big O of 2 to the n. Formally, it's absolutely wild, and I recommend you take Comp 3170, Analysis of Algorithms and Data Structures, to get a taste of complexity theory and understand why, if you're able to figure out a fast algorithm for any of these, you could literally win $1 million. I think it's called the Millennium Prize. But don't try that. We're going to focus on that slow exponential time algorithm. You basically have no choice but to go through every possible subset of the vertices of a graph and then check if that subset of vertices is the solution to the problem. Next up, we'll return to heaps and priority queues. And this will have you implement the stuff we talked about in class, and also implement a new operation that I haven't told you about, which is merging heaps. So you'll have to figure out an algorithm to merge the contents of two heaps while maintaining the heap property. And there are a bunch of specific details to do with the scenario. From a high level, this is really about heap merging. And then some proofs. Found a way to relate graph theory to asymptotic notation. So this is basically enforced exam studying. I just wanted to throw in some sort of asymptotic notation question. So this will have you reason about graphs and then prove a fact using all the techniques you've learned. And then this one, I'm not sure if I'm going to include it. It's cool, but it's going kind of off the rails of the course. So you may remember in assignment 4, you had a node class, and you're supposed to implement a stack or a queue. And you probably used a linked list for at least one of those, especially since implementing a queue using an array is a major pain. So I had this node class, and you're supposed to store it in a linked list, but you weren't supposed to make the linked list out of nodes. You have to make a specialized linked list node class that carries nodes. It was whack. It was worth it to be able to store binary tree nodes in the data structure during the traversals, but it was weird. Additionally, this might have made you start thinking about how annoying it is to make a specialized data structure for every type that you store in there. So you made a node queue or a node stack, and then if you wanted to make an int queue or an int stack, you would have to copy and paste it into a new file, replace all the nodes with ints. The way real data structure developers do it, use a thing called generics. This is the part that's going kind of off the rails of the course. Generics aren't part of the curriculum. I have no slides about them, and I don't particularly feel like making any slides for them. So this question would have you sort of self-directedly figure out what generics are. Give you some documentation, but you'll probably have to do a lot of Googling. And then you'll modify the data structures you made in assignment 4 to store objects of any type. Then in your stack and queue tests, you'll make those data structures store ints. So that'll make it much more elegant than the indirection of your stack and queue storing nodes that store ints. And then you'll do the same with the binary tree, but it'll be a bit more complicated because the structure of a binary tree, where things are stored, depends on elements being greater than or less than each other. It's a binary search tree property. So you'll have to do a bit more work to ensure that your binary tree can hold any type as long as it's something that could be compared. In more concrete Java terms, any object that implements the comparable interface. And then just to show off your mastery of the compare interface, modify your binary tree test to use fish, from the 3rd assignment. It would work just as well for integers because integers are comparable, but fish are more fun. So like I said, not sure if I'm actually going to include this. I think I will because generics are relatively easy to grasp, but I think I'm going to do something like not make this worth many marks, maybe even make it a bonus question, or talk more about generics in class. So that's the overview for assignment 5. Like I said, not sure if I'll have this released by the end of the day. I have to make the solutions and the rubrics before finalizing this. But if the release of the assignment is delayed, I'll push back the due date accordingly. Any questions about it? Yeah?
Generics, the one with you put T at the top, or whatever you want to call it, you put that inside of that structure.
Yeah. I'll try and find an example. Okay, so
Yeah.
yeah, along with your class definition, you have a generic type. T is a placeholder for anything. So if you instantiate generic class int, then data will be an int. If you instantiate generic class fish, data will be fish. So wrapping your head around the notion of a placeholder type and learning how to impose certain restrictions on that type for the sake of comparable stuff will be the source of difficulty for that question. Anything else? Yeah?
If we put a semicolon after that T, and then put down like, I don't know, you made a pre-made type or like protocol, whatever, is it gonna make T that protocol, or is that a different language?
Um,
Or, you know, making T a specific, you know, what is it called?
method or function?
Yeah, like, but it's not like saying T has to be integer.
Mhm.
T could be any, you know, any class associated with this. Is that this one? Is that this one?
I don't quite understand the question, but it sounds similar to the stuff about interfaces and comparable. Yeah, can you just ask your question again?
Like, I don't know if we screw this up, but you know how we can have like classes where you can have like, you can have like super class, subclass. I would think the super sub makes sense. Like another one, right? So you have like the base class.
Yeah.
But then all the ones that are above that class, right? Reference back to that one.
Yeah.
And the format can be called this in the same function as the base, right? Because they all end up having it. But in this one, if we do like T and a semicolon, whatever, I don't remember what it is exactly. Is that when T has to be a
Oh. Yeah. I think I get what you're saying, and I don't actually know the answer, but I kind of do. You can definitely make it so T has to implement a certain interface. That's what you're going to do with the binary tree. But I don't know if you can say that T has to extend a specific type. Actually, if you want like an object of some subclass of a base class, you could probably just make a variable of that base class, and then you wouldn't need to use generics.
What about what you support multiple different base classes?
Yeah, true. In that case, I fall back to my earlier answer. You can definitely make it so the generic type can use a specific interface, but I don't know if you can make it so the generic type uses a specific class, like a base class. I'm going to try Googling that. No, this isn't relevant. One of us would have to do some more digging to find out the real answer. A quick Google didn't return any relevant results. This is something totally irrelevant to your question.
Yeah, that's not the.
Yeah,
That is interesting to do that.
I agree. It's neat, but irrelevant.